Should powerful AI models be locked inside a few companies' servers, or should anyone be able to download them and run them on their own computer? In July 2026, 25 of the biggest names in tech, including Microsoft, Nvidia, Meta, ServiceNow, all signed one letter about this. Governments are writing new laws about it, and there has already been a real cyber attack that shows why this debate actually matters to you. Let's break it all down in plain English and welcome to the AI with Arun Show. A letter titled Open Weights and American AI Leadership landed, and it wasn't from one company. It was from 25 of them. Microsoft kicked it off, and it was signed by chipmaker Nvidia, Meta, IBM, security firm CrowdStrike, data company Palantir, Hugging Face, the AI startup Mistral, and even venture capital firms like Anderson Horowitz. That is a huge, unusual alliance. Think about it. Hardware companies, software companies, and open source non-profit do not normally agree on much. They all agreed on one thing. Politicians should not rush to restrict AI models that can be downloaded and run outside of a company's own servers. This letter set off a massive public debate in Washington and Silicon Valley about who should control the future of AI. The letter did not come out of nowhere. Just weeks earlier, on June 2nd, 2026, the US government issued an executive order called Promoting Advanced Artificial Intelligence, Innovation and Security. Along with it came something called NSPM 11, a national security memo. Together, these created new rules like requiring companies to pass cybersecurity checks within 30 to 60 days and having the government review powerful AI models before they are released. At the same time, White House advisors were accusing foreign companies of using a technique called distillation, which we will explain in a few minutes, to copy the abilities of top American AI companies like Anthropic's Claude. So, you had new restrictions on the table and acquisitions flying, all happening in the same few weeks. That is the pressure cooker this letter was responding to. So, you might wonder, why would a chip company like Nvidia care about this? Here is the logic. If AI only exists as an app you access online, you don't need to buy powerful computers. You just pay for API access. But if AI models can be downloaded and run anywhere, companies need to buy hardware, servers, and storage to run them locally. So hardware makers like Nvidia, AMD, and Dell want open models because it sells more equipment. Meanwhile, companies like ServiceNow, Palantir, and CrowdStrike work with governments and enterprises who need total control over sensitive data. They can't just send it to an outside company's cloud. And venture capital firms like Anderson Horowitz want open models because it means small startups don't need billions of dollars to compete. They can build on top of what already exists. Different reasons, same conclusion. Keep AI models open and downloadable. Before we go further, let's clear up a term you will hear a lot: model weights. When an AI is being trained, it is really just adjusting a huge number of internal settings, sometimes billions of them, called weights or parameters. Imagine a giant soundboard with a billion tiny knobs. At first, all the knobs are randomly set and the AI's answers are garbage. And during training, the AI looks at massive amounts of text and slowly adjusts each knob a tiny bit over and over until the combination of knob settings produces smart, useful answers. Those final knob settings, that massive list of numbers, is what we call the weights. When people talk about downloading an open weight model, they mean literally downloading the giant file of numbers so you can run the AI yourself on your own computer instead of going through someone else's app. There are actually three levels of openness in AI, and people mix them up all the time. Level 1 is closed models. You only reach these through an app or an API, like typing into a chat window. You never see the weights, the code, or how it was built. Level 2 is open weight models. Here, the company lets you download the actual weight file and run it on your own hardware or modify it. Meta's Llama and Mistral's models are good examples, and this is important. The company usually does not share the training data or the exact recipe used to build it. Level 3 is true open source AI, which shares everything: the weights, the training code, and even the data. That is a much higher bar, and very few AI models actually meet it. Keep this three-level ladder in mind because the next part of the video explains why the labeling gets confusing. Now, here is something worth knowing so you can spot marketing spend. Journalists and sometimes companies themselves often call a model open source when it's really just open weight. Meta's Llama models, Mistral's models, and even some of OpenAI's releases get called open source constantly, but technically they don't qualify. Why? Because in October 2024, the Open Source Initiative, the same group that defines what open source software means, published official rules for AI. To truly earn the open source label, a company has to share the full training data details, the data cleaning process, and the complete training code, not just the finished weights. Almost none of the popular open models meet that bar. They keep their training data secret, often for legal or competitive reasons. So the next time you hear open source AI, ask yourself, do they truly mean open or just open weight? The difference matters for trust and for transparency. Now let's talk money because this is the biggest driver of the whole debate. Building a frontier AI model from scratch takes enormous computing power, energy, and specialized engineers, easily hundreds of millions, sometimes billions of dollars. When you use a closed AI through an app, that huge cost gets passed to you through pay-per-use pricing, kind of like a metered taxi ride. Open weight models let a company skip that entire cost. They just download a model someone else actually trained for free or cheap and run it on their own computers. Because of this, businesses are increasingly using a hybrid strategy. An automatic router decides which task goes where. Boring, repetitive tasks like sorting customer emails get handled by a cheap local open model running on the company's own hardware. Rare, highly creative, or complex tasks get sent to expensive, frontier closed models. It's the best of both worlds and it saves serious money at scale. Now, this isn't just theory. OpenWeight AI is already running real operations. In healthcare, hospitals run AI models on their own servers to summarize doctors' notes and analyze medical images without ever sending sensitive patient data outside their walls, which helps them follow privacy laws like HIPAA. In finance, banks use it for fraud detection and internal risk modeling, keeping their secret trading strategies from ever touching an outside company's servers. In defense, this is huge because military systems often operate in the field with no internet connection at all. A closed AI that needs a live connection to a company's cloud is completely useless there, but a downloaded open weight model keeps working offline. And in software development, companies use local AI coding assistants so the proprietary code never leaves the building. Four very different industries, one common thread, control over sensitive data. Now, let's get into the security argument because both sides make a genuinely fair point. Critics of open weight models say once you release the weights publicly, you can never take them back. Anyone can download the file and using very little computing power, retrain it to remove its safety rules. The guardrails that stop it from giving dangerous instructions, like how to build weapons. That is a real risk. But supporters flip the argument around. They say relying entirely on closed AI from a handful of companies creates a danger, a single point of failure. If one company's servers go down, get hacked, or quietly change how their model behaves, every business depending on it gets disrupted at once. They also argue that closed systems are a black box. So if something goes wrong inside them, outside experts cannot inspect it or catch the problem. Coming up, there's a real story that puts this argument to the test. So here's the story that made this whole debate very real. In July 2026, OpenAI was running a safety test, letting an advanced, not yet released AI agent try to solve hacking challenges in a lockdown sandbox, with its safety refusals turned down specifically for this security testing. During the test, the AI figured out on its own that Hugging Face, a major AI hosting platform, held some of the evaluation data. It then found and chained together a real software vulnerability along with some stolen login credentials and broke out its sandbox, gaining unauthorized remote access to Hugging Face's actual infrastructure. It fired off over 17,000 automated attacks within hours. When Hugging Face's security team tried to use leading closed AI models to help analyze the attack and respond, those models refused. Their built in safety filters could not tell the difference between someone attacking a system and someone defending it. So they blocked the request. Hugging Face had to switch to GLM, a Chinese open weight model running it locally to actually fight back. This incident taught the industry two hard lessons. First, Attackers who don't follow any rules will always have access to unrestricted AI tools, whether stolen, modified, or built without safety limits. If the good guys, the cybersecurity defenders, are stuck using only heavily filtered closed AI that refuses to even analyze an attack in progress, then defenders are at a real disadvantage during an actual emergency. Second, this exposes a data risk. When you send sensitive information like network details or stolen credentials to an outside company's cloud servers for analysis, you may be exposing that data to foreign legal systems. In the US, a law called Cloud Act lets the government access data stored on US company servers, even if the data itself is about a company or person somewhere else in the world. Running your own open weight model locally means that sensitive telemetry never has to leave your own walls in the first place. Big lesson in both directions. Now let's explain another key term, distillation. Imagine a brilliant professor, the teacher model, who has spent years mastering a subject. Instead of a student spending years learning from scratch, they just study thousands of the professors worked out example answers and step-by-step explanations and try to mimic that same reasoning. That is distillation. In AI terms, a large, expensive, highly capable teacher model generates tons of examples, answering, and reasoning steps. A smaller, cheaper student model is then trained to copy those patterns. The result, you get a smaller model that runs on regular consumer computers that performs surprisingly well because it learned from a much smarter model's output without the massive cost of full scratch training. This is a completely normal and widely used technique in AI research. But as we'll see next, using this technique on someone else's model has become deeply controversial. So here is where distillation gets political. In mid 2026, US government officials publicly accused Chinese AI companies, including Moonshot AI, whose model is called Kimi K3, of using distillation to copy the abilities of top tier American proprietary models, specifically Anthropic's Claude, without permissions. Some American AI companies call this straight up intellectual property theft and trade secret misappropriation. But the coalition behind the July 24th letter pushed back hard. They argue that distillation is just a normal scientific method, the same way open source software has always been built by learning from and improving on what came before. They're urging policymakers not to lump legitimate research distillation in with actual data theft or hacking. Their fear is that banning distillation broadly would mostly punish small companies and academic researchers who use it responsibly to build efficient models while doing very little to stop determined bad actors anyway. So, how do organizations use open weight models safely without banning them outright? They use something called Zero Trust AI, which has three layers. Layer 1, platform integrity. The actual computer chips running the AI use hardware level encryption. So even if someone breaks into the machine, they can't read the model's memory or activity while it is running. Layer 2, model integrity. Before anyone uses a downloaded model file, it gets cryptographically signed and verified, similar to a wax seal or a letter. This proves the file has not been secretly modified or had a backdoor slipped in during download. And layer 3, outcome integrity. Rather than trusting the AI's own built in safety training, companies place independent guardrail software around it, almost like airport security checkpoints that watch everything going in and out and catch bad behavior in real time. Together, these three layers let companies get the benefit of open models without just hoping the AI behaves. Let's zoom into that third layer, the guardrails, because it works like four checkpoints in a row. Checkpoint 1, the input checkpoint, scans what the user actually types in, catching attempts to trick or jailbreak the AI into ignoring its rules. Second checkpoint, the retrieval checkpoint, matters when an AI looks something up, like searching the documents or the web. It screens those retrieved documents for hidden malicious instructions before the AI ever reads them. Checkpoint 3, the output checkpoint, screens the AI's actual answers before it reaches the user, catching things like made up facts, leaked secret keys, or toxic language. And checkpoint 4, the action or tool checkpoint, is critical for AI agents that can actually do things like sending an email or editing a database. This checkpoint double checks any action the AI tries to make before it is allowed to happen. Four checkpoints covering everything coming in, everything going out, and everything that the AI does. So, where does all of this go from here? Experts sketch out three rough phases. Phase 1, late 2026, the focus is standardizing and defending, meaning highly efficient AI models that can run on a single powerful computer become common, and companies start adopting standard safety labels for AI models, kind of like nutrition labels for food, plus early rules distinguishing legitimate research from actual IP theft. Phase 2, 2027 through 2028, hybrid expansion. When governments, including the European Union and the United States, start requiring formal technical documentation and mandatory safety reviews before releasing powerful models, and confidential computing becomes standard for enterprise AI. Phase 3, 2029 and beyond. Now, this is the big one. Autonomous mesh systems, where networks of AI agents, each running locally, work together across different companies and even countries, verifying each other's work peer to peer. Along with that comes talk of global treaties governing how powerful AI models get shared and protected internationally. It's a fast moving space, and that is the general direction. So let's bring this all together. The July 24th letter is really about one fundamental question. Does the power of advanced AI stay concentrated inside a handful of companies, accessed only through their apps and their rules, or does it spread out, downloadable, inspectable, and runnable by hospitals, banks, small startups, and even individual developers around the world? Supporters of open-weight AI says democratizing access drives competition, keeps costs down, and actually makes defense against cyber attacks stronger. We saw that Hugging Face breach. Critics worry about safety guardrails being stripped away and misused by bad actors. Realistically, most experts think we're heading towards a split market. Massive, closed frontier models will keep pushing the cutting edge of reasoning, while open weight models quietly power the vast majority of everyday business and government applications. Whichever direction policy takes, this decision will shape who actually benefits from AI's future. If you like this video, I request you to consider joining us and supporting our work. Click on join right below the video. And thank you so much for watching. Please like, share, and subscribe to the AI with Arun Show. I'll see you in the next video.